Hey there, Robert here. The moon looks very nice tonight. It would be a shame if it were to disappear. Before we can understand what happens if the moon were to disappear, we have to understand how the moon currently affects Earth. Currently the Earth is 340,000 kilometers from the moon and it is increasing at a rate of 4 cm per year. The current force exerted by the moon on the Earth is 2 times 10 to the power 20 newtons, using the formula F equals g m1 m2 over r squared. And due to this force, the Earth's oceans are forced into an oval shape, with two simultaneous high tides, one facing the moon directly and the other on the other side of Earth. If the moon were to fully disappear, the tides would be much smaller, and it will only be due to the sun's gravity. Now let's think about what will happen if the moon were to be reduced in size by 70%. The changes will be quite interesting. First off, there will be no more total lunar eclipse and we will only have annular eclipse. Next, due to the much faster spin of the Earth relative to the moon's orbital speed, the high tide facing the moon will be dragged in front of it slightly due to inertia. A moon with a smaller mass will correspondingly lead to smaller tides on Earth. The smaller tides will have less mass compared to the initial high tides, hence there will be less mass to influence the moon's orbit. This will result in a smaller moon being closer to the Earth, which also creates less drag on Earth, causing our planet to speed up. A 30% size moon would result in our days being 5 hours long instead of the usual 24 hours. Now that you know what will happen if the moon were to disappear, do you want to know how to go about causing it? Well, to do so, we need to know the energy holding the moon together in order to know how much energy is needed to overcome the forces. Luckily, we have the numbers. And the gravitational energy holding the moon together is equals to 1.24 times 10 to the power 29 joules. And that is how much energy is needed at minimum to destroy the moon. Now, if we were to destroy the moon using TNT, given that 1 ton of TNT releases 4.14 billion joules of energy, we would need 3 times 10 to the power 19 tons of TNT to blow up the moon, equivalent to a sphere of 470 kilometers in diameter and of 30% of the mass of the moon itself. And that is assuming the TNT doesn't have energy holding itself together. If you want to be creative and using unorthodox methods of destroying the moon, such as launching a bowling ball at the moon, you can do so. But be prepared to break the universal speed limit. If you were to use a 7.2 kg bowling ball, it will have to be travelling at a speed of 1.86 times 10 to the power 14 meters per second, 600,000 times faster than the speed of light. If you want to accelerate the bowling ball at 981 meters per square second, you will need 6,000 years. And using v square equals u square plus 2as, you need to start accelerating from 1.8 billion light years away, 18,000 times the length of the Milky Way. And using F equals ma, you will need to constantly apply 7,063 newtons of force every second, a total of 7.42 times 10 to the power of 30 newtons, so I recommend that you stick to using TNT or Linux. In conclusion, let's all be thankful that no one is able to destroy the moon currently. Thanks for watching.